single numbers that I want to evaluate the absolute value of this single number. Okay? So then this will be just xy. Do you understand why? Huh? Okay? Which is also equal to the absolute value of x, absolute value of y. Because s is positive. Since s is positive, it's equal to absolute value of x. Since y is positive, is equal to absolute value of y. Okay? And this is the case 1. You can actually look at the other case. Case 2 is the setting where x is positive and y is negative. Case 3 is s is negative and y is positive. And case 4 is both of them are negative. Okay, let's try to see this one. So the absolute value of x, y, the product will be negative. Right? The product is negative. Because one of them is negative. The product will be negative. So the absolute value of a negative number is the negation. So it's minus of xy. Okay? So this I can just rewrite it like this. Yes or no? Oh, no. I think it's better that I write it like this. Okay? Yes. So x is positive. So the absolute value of x is still x. Y is negative. The absolute value of y is equal to minus y. So we have proved the statement. Okay? Any question? Any question? Yeah. Huh? Case 2. Yes. So I'm taking two variables where one is positive and the other is negative. Okay? So if one is positive, the other is negative, the product will be negative. And I want to evaluate the absolute value of a negative number. And the absolute value of a negative number, I've said, I'll just delete the definition. Absolute value of a negative number is the negation of that number. Okay, so you will actually evaluate the absolute value of this number that you are saying is negative. So by definition, so you can just see this as A. And this is A. But A here is negative. Your A is negative. You see that? So I just write it down. Okay? But remember that I want to show a statement. So actually you can just distribute the minus over here on the y side. Okay? And we know that since x is positive, the absolute value of x is equal to x. And since y is negative, the absolute value of y is minus y. So you have the equality. It's clear? Okay. So in the same way now, we can also another property, this is number 5 or 6. So for every x, y in R, such that y is different of 0, the absolute value of x over y is equal to the absolute value of x divided by the absolute value of y. Okay? And you can do it, the proof. Why is it true? Because it must, in every statement, you need to give the argument why this is always true. Okay? You can try to do it by a second. Why it's true? As I said, you can use actually the first one. Okay, let me give you a hint. Okay? So you know that 1 if you want to evaluate x divided by y is equal to x y index. Huh? Okay? Now, you can use the previous one.
This thing.
Since we know that the previous statement is true, then we can use it. Okay? From the previous property. X is a number. Y index is a number. Okay? So by the property 4, I can write that this is equal to the absolute value of x multiplied by the absolute value of y index. Yes or no? Okay. But now there is a problem because what is the quantity of this one? The quantity of y index. Is it equal to 1 over y?
Yes.
In another way, you are saying that the absolute value of minus the index is equal to y. That's what you're saying, eh? It's not the same writing, eh? But you know why is it true? You know why is it true? You know the reason why. Okay? If you take y inverse, you multiply by the y himself, it will give you 1. Right? If you take a number and you multiply by its multiplicative index, it will give you 1. Okay, so this gives you 1. And the absolute value of 1 is 1. Okay? And this if you apply the property 4, it will give you the absolute value of minus y multiplied by the absolute value of y, which is equal to y. Then the absolute value of minus y is equal to 1 divided by absolute of y. Do you see now? So now we can take this quantity and we replace it here over here. We take this quantity, we replace it over here, and then we get the result. Okay? It's becoming too much, eh? It's becoming too much. Alright, we move now. Another property, yes. Yes, so actually we want to prove. So you don't need to prove it. You don't need to show this the statement that I'm doing. I'm writing it. You just need to know that whenever you want to evaluate the absolute value of s over y, it is always like this. Always. Okay? Always. You should know that it's a property. But why it is true? To prove that, you can use the previous statement. We have shown from the previous statement that the absolute value of x multiplied by y is equal to the absolute value of x multiplied by the absolute value of y. You can use that. And then you need to write this quotient in a form of multiplication. In a multiplication form. Okay? So that's why I wrote this. And actually, if you apply the property 4, you get this. But then, remember that we want to actually prove that this quantity is equal to x, absolute value of x multiplied by 1 divided by the absolute value of y. So we want to understand why this quantity here is equal to this. So that leads me to write this. The absolute of minus 1 multiplied by y, take the number, you multiply by the inverse, you see that it gives you 1, the identity. And then from there you can evaluate the absolute of minus y, which is 1 over y. Okay? So for the sake of time, let's continue. This now is another important property, yes? The triangle inequality. Okay, so we call a triangle inequality. So for every x, y in R, if I want to evaluate the absolute value of x, plus the absolute of y, it always be less equal to the absolute of x plus the absolute of y. It is always true. Okay? It's always true. But why is true? And I say again, if you take two numbers and then you are, those property, you will use it whenever you are doing the calculation. But now, I want to show you why it is true. So if they ask you to calculate these kind of things, you don't need to use the proof. But you need to understand why it is true. Okay, so let's see why this is true. So if you want to show this inequality, is an inequality here. So you can start from here and then find out that you have this this quantity. Okay? So the absolute of x plus y by definition is what? Is equal to square root of a plus b square, right? You can write it like this. Yes or no? Yes? It's true. From the property that we gave for number 3. Okay? So you can actually do the development. So this is equal to a squared plus 2ab plus b squared. Okay? This is true, Okay, so from there, we know that if you take any number, this is known. This number is always bounded by the absolute of x and the absolute of minus x and x. This is a knowing. This is always true. Okay, so that means that if I'm taking AB, I can take AB as one quantity. So AB here, I can write that AB is less equal to the absolute of. Do you agree with what I wrote? You agree with this? This just from this statement. This is always true, eh? So I took the second side. Okay, so I can still write this. I can still write that this is equal to the absolute value of a squared plus 2ab plus absolute value of b squared. Because we have shown that at prior, maybe statement 4, that the absolute value of a squared is equal to a squared. We have shown that's why I can write this one. Okay? So since we know that AB is less equal to AB at the absolute value, then we got already the inequality. So then this one now will be less equal to the absolute value of a squared plus 2ab plus b squared. Okay? Remember, this is an equality. But from here to here is the inequality. It's because of this statement. This inequality comes from this statement. So since we have this, then we have this inequality. And we also know that the absolute of a, b is equal to the absolute of a divided by the absolute of a. Okay? So I can still write this plus 2ab plus the absolute